So here's another use of the double angle formulas. What we can do is actually reduce the power of a function using the double angle formulas. So right now, if you were given sine squared x, all you could do is replace it with 1 minus cosine squared x, and vice versa, cosine with a sine squared, tangent squared with a secant squared. But what if you want to reduce the power, get it down to just plain old sine or cosine? Well, if you take your double angle, so for sine squared x, we would have this. So if we solve for sine squared of x, you get cosine 2x minus 1 divided by negative 2. We end up with sine squared x is equal to this. So a little quick modifying, that negative will change the signs at the top, giving us 1 minus cosine 2x all over 2. So now we have taken our sine squared and reduced its power down to a cosine squared. So it's the half angle, just stopping in the midpoint. We could do the same thing for cosine now. By the way, this is now replaceable. So if you see sine squared of x, you can replace it with 1 minus cosine 2x over 2, something to put on your card. So cosine 2x plus 1 divided by 2. And we end up with 1 plus cosine 2x, just to keep it in that order, over 2 cosine squared x. So now we can replace a cosine squared x with something that reduces its power. So there's no more power here. That's the key. And if you put these together, you get tangent. So sine squared over cosine squared would be that one divided by that one. And there you go. So how do we use this? Well, let's just say we want to get rid of the power of a sine to the power of 4. So sine to the power of 4x is sine squared x times sine squared x, because 2 plus 2 is 4. And then now you can come back up here and go, okay, well, that's 1 minus cosine of 2x over 2 times 1 minus cosine of 2x over 2. And there you go. No more powers. And yeah, you can keep multiplying it out, and that's where the not fun part should be done. And we're going to stop here. But there you go. So to reduce powers, just use your double angle, solve for the square part, and you're good to go.